Okay, this lesson is on independent and dependent events. So the probability is different depending on if two events impact each other's probability. So independent events are two events that the outcome of one or the occurrence of one thing does not affect the probability of the other. So an example of two independent events would be just tossing a coin twice. So let's say I toss the coin the first time, I can get a heads or a tails. Now that doesn't change what I can get on the second toss. On the second toss, I can still get a heads or a tails either way, regardless of whether I got a heads or a tails the first time. So they don't impact each other. So if two events are independent, meaning they don't impact each other, then the probability of A and B happening is really easy to find. You just do the probability of the first thing times the probability of the second thing. So let's take a look at something that's independent. A six-sided cube is labeled with the numbers 1, 2, 2, 3, 3, and 3. Four sides are colored red, one side is white, and one side is yellow. Find the probability. So it says find the probability of tossing a red, then a white, then a yellow. So really, the first time I roll, I could get a red, okay? Then the second time, the fact that I got a red or something else the first time doesn't change my chance of getting a white, and then that doesn't change the probability of you getting a yellow. So these are independent events, so three independent events. So I just need to find the probability of each and multiply them. So the probability of getting a red, there are 4 red out of 6. There is 1 white out of 6, and there is 1 yellow out of 6. I want to reduce this first fraction so that I have it a little bit easier. Okay, now I just multiply these 3 fractions. So just multiply across the top and multiply across the bottom. 6 times 6 times 3 would give me 36 times 3, which is 108. And then if I reduce that, that would be 1 over 54. So the chance of me tossing a red, then a white, then a yellow when I roll this cube 3 times would be 1 out of 54. So pretty low. Okay, what if you have two events where the occurrence of one thing does impact the probability of the other? So then this is how you do that. You do the probability of the first thing, probability of A, times the probability of B, and then there's this weird notation you see here, right there. This means, right here, means B, what's the probability of B given that A has already happened? So assuming, what's the probability of B given that A has already happened? Okay, so let's take a look at this. Here is a bag, and inside the bag we have 2 lemons and 1 lime. If I draw out of this bag, the first time I draw, my chance of getting a lemon here is 2 out of 3. Okay? Now, if I don't put that lemon back, okay, I keep it out. Now my next one, I have 1 lemon and 1 lime left. So the chance of me getting another lemon has now changed, right? It's gone from 2/3 to 1/2. So now the second draw is different because I did not replace the lemon the first time. So that's why the first probability, what happened with that, does impact my second one. And so you could see if I went down the other path here, what if I drew a lime the first time? Okay, there's only 1 lime in there. Now the second time, I have to get a lemon because there's no limes left. So you can clearly see that the first draw definitely impacts your probability, the second draw. So because I didn't replace it. Okay, so those are called dependent events. So let's do this with a little bit more challenging situation. So it says 2 number cubes are rolled. Here's all the possibilities, right? Those, you've seen this grid before, 36 options. What is the probability that the red cube shows a 6 and the sum is greater than 9? Now, the probability of the first thing, I want to find that. The probability that the red cube shows a 6. So probability, let's kind of write this out. I'll use maybe a different color. Probability red 6 and sum is greater than 9 should be equal to, and I'm just going to write this, the probability of getting a red 6 times the probability that the sum is greater than 9, given that I'm talking about only a red 6. That the red 6 has already happened. And because that impacts the probability, the first thing impacts the second one. Okay. Now, let's see if we can figure out what these are. What's the probability of getting a red 6? Well, you can see these are all the ones that have a red 6, right? There are 6 out of 36. So let me write this in a different color right here, right above this. Probability of getting a red 6 is 6 out of 36. And I want to multiply that by, okay, now it says the probability that the sum is greater than 9, but the red 6 has already happened. So that means I have to only look at this row because these are the only ones that have a red 6. We're assuming that that has already happened. So now that impacts my probability because I'm only looking at that line, not all 36. So how many of those ones that I circled have a sum greater than 9? So no, this is 8, greater than 9, so this one won't work. So these 3. So that is 3 out of 6. Okay, now I'm going to reduce those to multiply. So the first one was 6 out of 36, which is 1/6, times 3 over 6, which is 1/2. Multiply those together, I get 1/12. So the probability the red cube shows a 6 and the sum is greater than 9 is 1 out of 12. So a little tricky. These can be kind of hard. All right. How about this second one? Let me erase this. This might be a little confusing. So I'm just going to get that out of there. All right, now the blue cube, probability the blue cube shows an even number and the sum is greater than 5. So we want to, these are dependent events, so probability blue is even times the probability that the sum equals 5, given that blue is even. That's how we have to find this. So let's see if we can figure out blue is even. Well, 2, 4, and 6 would be our even numbers for blue. So that is, let's see, 6, 6, and 6 is 18 out of 36. Or 18 out of 36 is a half. So that's 18 over 36, which reduces to a half. So I'm just going to use a half. Simplify it right away. Okay, now, of the ones that I circled, I should maybe circle this a little bit better. I'm only looking at this right here. Of the ones I circled, how many of those have a sum equal to 5, just the circled one. So that's only 18. So that's this one, and none in the last one. Okay, so that's 2 out of 18, which reduces to 1/9. So let's just go 1/9. That'll make it easier for us to calculate. Okay, so if I do that, 1 times 1 on the top is 1. 2 times 9 is 18. So the probability is 1/18. Okay. Again, these can be a little tricky. Now, sometimes you can be given a chart, and these, it's like the wording is really important. But the chart should make it a little easier. Okay. Find the probability of each situation. That an immigrant, okay, is from the West. So in this case, you want to look at just the immigrant column, because they're saying, hey, we're telling you that these are this column, okay? And they're from the West. So we want to first know what the total is there. So I want to add up that column first. If you do that, you should get here on my calculator, I got 11,656. Okay, now how many of them, so that would be my total, that's the denominator. And then how many of them are from the West? So that would be, that's my numerator, 2,654. Now, I'm going to put that into decimal form. So if I do that, let's see, 2,654 divided by 11,656. You get about 0.227, so we're going to say 0.23. So about 23% chance that that is true. Okay. All right. It says that the next one here says that, let's get rid of that. Someone selected from the South. Okay. So this time we're saying someone selected from the South. Okay. Is an immigrant. Okay, so South, if I add those two first, that would be my denominator. If I do that, I get 80 to 85. And then from the South is 5,042. There we go. Okay, now I just want to divide those two things. If I do that, I get 0.609. So let's say 0.61, we'll round that. So about 61% chance. Okay, now this one is a little tricky. It says that someone selected. So that someone selected is the whole chart. Okay, so in this case, you're looking at, they're just saying, all right, what's the chance that someone selected from this survey is an immigrant and from the Midwest? So you're just saying the whole chart. Now I'm going to add up all this stuff. Now, if you do that, I did that ahead of time here because I knew that was going to take me a while. And you get 23,311. And then I just want to say, what is the one that's an immigrant and from the Midwest? So that would be 2951. Okay, and then if I divide those two numbers, I get about 0.127, which is 0.13, about 13%. Okay, so sometimes on the chart, but you got to read these very carefully. It's a little confusing sometimes, so read the questions carefully, and you should be able to get it. Okay, now probably most of you are familiar with a deck of cards. Some of you may be more familiar than others, but let's find the probability. Selecting 2 hearts when the first card is replaced. So first of all, because the card is replaced, these are independent events. It's an independent event. So the first draw does not impact the second draw. So what's the probability of getting 2 hearts? So then it would just be the probability of getting a heart the first time. I don't know what's going on here. There we go. And times probability of getting a heart the second time. So probability of getting a heart, you can see there are 13 out of 52. Oh, everything is just disappearing on me. There we go. 13 out of 52 and 13 out of 52. Now 13 out of 52 is 1/4. So really I would just say that's 1/4 times 1/4, which is just 1/16. So the probability of getting 2 hearts when you replace the first one is 1 out of 16. So I'm gonna erase this here and put it there. Okay, now selecting 2 hearts when the first card is not replaced. So we already know that the first time you draw when is 13 out of 52. Now, if I don't replace the card, then I want to assume that the first card is a heart, right? Because it says probability of the second thing, assuming the first thing had happened. So now, assuming I got a heart to the first time, there's 12 left. There's also only 51 cards. So I want to do 13 over 52 times 12 over 51. So this would be 156 over, and then that's 26, 52, 26, 52. Okay. Let's see what this is. Maybe reduced. 1/17. Okay. What is the probability that a queen is drawn, not replaced, and then a king? Well, there are only 4 queens. If I don't replace it, there still are 4 kings because I drew a queen the first time. We assume that we drew but there's only 51 cards. So now I would have 16 out of 2,652. And then I'd want to reduce that, which would give me like 4 out of 663. Or you could do the percentage or the decimal, which would be like 0.006. So less than 1%. So it's a really small chance. Okay, hope that makes sense. See you later.